You ever look at the name of a chemical, one of those super long, complicated ones, and your brain just shuts off? Yeah, mine too. But behind those intimidating names is this incredible story, one of science's greatest achievements, really. It's the story of how we created a single, universal language that everyone, everywhere could understand. So, let's get into it.
And we're going to start in a pretty unexpected place, the classic novel Don Quixote. In this line, a character is describing a woman, and to do it, he uses the chemical terms of his day. He says vermilion and sulfur are flowing from her eyes. Vermilion, by the way, is this bright red mercury compound.
For hundreds of years, this was pretty much how chemistry was talked about. It was poetic, right? It was literary. But it was also really, really imprecise. And for science, which is all about precision, that was a massive problem. This beautiful, kind of messy way of describing the world, well, it set the stage for centuries of confusion. So let's take a look at what that confusion actually looked like. Because before we had a system, the world of chemistry was basically the Wild West. For most of history, you had chemists and alchemists just using their own local, traditional, or sometimes just plain made-up names for different substances. Just imagine trying to copy a groundbreaking experiment from another country when you couldn't even be sure you were using the same ingredients. It was just scientific chaos.
The source material for this explainer puts it perfectly. The language of early chemistry was full of, and I'm quoting here, capricious and obscure expressions. The very same substance could have dozens of different names, all depending on where you were and who you were talking to. This made building on each other's work, well, nearly impossible.
To really get a handle on just how big this problem was, the authors of our source give us this really powerful metaphor.
And that just nails it, doesn't it? You've got all these brilliant scientists, like incredible musicians, but they have no shared music to follow. All you get is noise, not harmony. There was absolutely no way to build upon each other's work and create something bigger.
And look, this wasn't just some small inconvenience. This lack of a shared language literally stalled major scientific progress for centuries. So, how in the world did we finally fix it?
Okay, this brings us to the big turning point in the story. This is when scientists decided, enough with the noise, it's time to write the music.
The year is 1919. The world is just starting to recover from a devastating global war. And right in the middle of all this, scientists from all over the globe get together with this incredibly ambitious goal.
They form what's called the International Union of Pure and Applied Chemistry, or IUPAC for short. And they have one single driving mission: solve this language crisis once and for all. They were going to create that universal score for the orchestra of chemistry.
Their goal was, simple on the surface, but totally revolutionary in practice. They wanted to build a naming system based on 3 core principles. First, it had to be crystal clear, absolutely no ambiguity. Second, it had to be systematic, with logical rules that you could follow. And third, this is the most important part, it had to be based on global consensus. Everyone had to agree.
So, did they succeed? Oh yeah. Today, there are over 200 million registered chemical substances, and every single one has a unique, systematic name that any chemist anywhere in the world can understand and use to draw its exact molecular structure. This is so much more than a list of names. It's a map of our entire chemical world, a truly monumental achievement.
Okay, so why should this matter to you and me? Because this language isn't just for scientists in labs. As our source calls it, it's the language of things.
Yeah, this universal language is woven into the fabric of our daily lives. You see it in the precise formula for a new medicine, making sure it's safe and effective. It's in the composition of your detergent, the ingredients listed on your favorite drink, and the detailed results of a blood test. It's the silent language that makes global trade, safety, and innovation possible.
And the foundation of this entire language, its alphabet, its grammar rules, the whole shebang, is something you definitely recognize: the periodic table. Every single rule for naming those 200 million compounds is built right on top of this beautiful, powerful chart.
But believe it or not, the story doesn't end there. Creating the language is one thing. The final crucial step is making sure everyone can actually speak it.
I mean, think about it. Having a set of rules in English is a fantastic start, but it's not truly universal until scientists and students everywhere can access it in their own native language. And that brings us to the heart of what our source material is all about.
This is where the authors of the book we're talking about, Professors Ephraim Reyes and Pascual Roman, come into the picture. They took on the absolutely immense challenge of translating the official IUPAC rules into Spanish, a job that requires an incredible amount of dedication and precision.
And what they produced was the first ever single book of IUPAC's core rules that was officially approved for the entire Spanish-speaking world. This was a massive leap forward for scientific education and collaboration, making this universal language accessible to millions and millions more people.
And this is not a simple word-for-word translation. It takes careful negotiation and debate. Just look at element 117. The first proposal for the Spanish name was Teneso, but after a ton of discussion between different scientific academies, the final agreed-upon name became Tenesio. That tiny change, just one S, shows you the deep commitment to getting it exactly right.
Because these rules, they aren't just handed down from some committee on high. No, they are the living, breathing result of decades of discussion, revision, and global agreement. It's a process that ensures the language of science stays clear, effective, and truly universal for everyone. So this book, and the whole system it represents, is way more than just a set of rules. It's a symbol. It's a testament to what we can achieve when we decide to work together, across borders and languages, to build something that helps everyone. And that leaves us with one last thing to think about. Chemistry created a universal language that wiped out confusion and supercharged progress for more than 100 years. So you have to wonder, what else could we achieve if we applied that same spirit of collaboration to other complex fields? What other scores are out there just waiting to be written?